Heliophysics is the study of the Sun and its interactions with Earth and the solar system. Solar wind streams from the Sun carrying energetic charged particles. The Earth is protected from these particles by its magnetosphere. The Earth's rapidly spinning liquid metal core generates a magnetic field similar to a bar magnet, with a north and south pole. This field forms a magnetic shield. NASA's satellite observations have confirmed that this protective shield is always in place, but the solar wind causes it to change in size and shape. The pressure of the solar wind flattens the nose of the magnetosphere and drags the field lines into a tail. A bow or shock wave forms upstream, much like a boat moving through water, and most of the onrushing charged particles are diverted around the outer boundary of the magnetosphere, called the magnetopause. The inner magnetosphere is composed of three populations of charged particles that are trapped in the Earth's magnetic field. These particles move in circular motions, or gyrate, around the field lines but rarely interact with each other. The plasmasphere is comprised of low-energy particles that drift up from the ionosphere, forming a sphere-like reservoir of very cold but fairly dense plasma and co-rotate with the Earth. The ring current is the second population of particles and is comprised of medium-energy particles that drift around the Earth, with protons drifting in one direction and electrons in the opposite direction. The third population consists of high-energy particles that are trapped in two regions called the Van Allen radiation belts. These particles move along the field lines toward the poles until they are reflected back, creating a bouncing movement. Particles with a high enough velocity along the magnetic field will follow the field lines to the poles and enter the upper atmosphere. Charged particles from the Sun leak into the magnetosphere over the northern and southern magnetic poles and travel to the magnetotail, adding to a reservoir called the plasma sheet. Particles can also enter during magnetic reconnection. When the polarity of the solar wind is opposite to that of the magnetosphere, the magnetic field lines of the incoming plasma will connect with the field lines of the magnetosphere. This reconnection is an explosive process that catapults charged particles into the magnetosphere. Solar storms on the Sun can eject solar energetic particles and energy toward the Earth. The particles can enter the Earth's magnetosphere and add to the particles in the plasma sheet reservoir. Associated magnetic energy can also pile up in the magnetotail until reconnection explosively releases energy and particles into the inner magnetosphere. A picture of a circulatory system emerges as the particles add to the ring current and radiation belts. This phenomenon is not well understood yet by scientists, but whenever reconnection occurs, an explosive burst of plasma results. This ultimately disrupts Earth's upper atmosphere, causing auroras and space weather events. NASA's upcoming Radiation Belt Storm Probes mission will help scientists better understand the processes in the radiation belts. The magnetospheric multi-scale mission will bring clarity to the process of magnetic reconnection. Together, these new missions will unveil secrets of the magnetosphere and space weather.